Hello again, fourth grade math. Today we're going to be doing our chapter 13 review, and the pages for this review in your textbook start on page 566 through 570. And today for a review, I just thought I would model some of the questions that are in this section or this lesson, okay? Some of them might be on your assignment below this video. Some of them might be ones that we skip over, okay? But they're all just to show you and kind of model what you need to know, what you need to remember about fractions from this chapter, okay? So this one isn't from our book, but I just want you to think about what fraction is shaded of this shape. So I'm gonna start with my fraction line, and my denominator, the number that goes on the bottom, is the total number of equal parts. Okay, so my total number of equal parts in this shape are 1, 2, 3, 4. So my denominator is going to be 4. And the number of parts that are shaded, there's only 1. So the fraction that tells me the shaded parts of this figure is 1/4. Okay? All right, this one is also not from this lesson, but it just talks about fractions of a set of items or objects or shapes. Okay, so for this set, we have 3 green circles and 2 pink triangles. Okay, and I want to write a fraction of that models the part that is not green. Okay, so first, I'm going to start with my fraction line again. And I'm going to think about my denominator, okay? And again, my denominator is the total number of equal parts, so the total number of objects in my set. So I have 1, 2, 3, 4, 5 total shapes in this set, okay? So the part that is not green would be 1, 2, my 2 pink triangles. So the fraction that models the parts that are not green would be 2/5. All right, now we're going to do some problems that are from this lesson in our book, okay? So I'm gonna flip back. All right, so number 23 in your book, I've already written down some information from the question, but the question says, Marissa has a marble collection. 1/4 of her 16 marbles are blue. Her red marbles are shown below. The rest of the marbles are green. How many are green? So I drew the red marbles from the book, and there's 5 red marbles right here. And the first thing that we need to figure out, though, is these blue marbles. And it tells us that 1/4 of 16 are blue. So what I did to show a picture of this is I drew 16 little circles as my marbles. And what 1/4 of 16 means that I need to have 4 equal groups. And how many are in each of those groups is going to tell me what 1/4 of 16 is. So I've got 16 marbles here, and I'm going to break them into 4 equal groups. So that means that 1/4 is going to be one of these sections. So that tells me that 1, 2, 3, 4 marbles in her collection are blue. Okay, so now we've got 5 red marbles and 4 blue marbles, and we need to figure out how many are green. So she has 16 total marbles. So if we have 5 red and 4 blue, okay, we can add those together and we get 9. So how many are going to be left over? So 16 minus 9 is 7. So she has 7 green marbles in her collection. Okay? All right. Now we're going to look at number 27. Okay? And this is now on page 569. And it says, write an equivalent fraction for 6/8. Okay, so an equivalent fraction, if you remember from lesson 13:4, is a fraction that is equal 2 6/8, but it has a different numerator and a different denominator. So one way we could find a equivalent fraction is to multiply. Okay, so if we're going to multiply to find an equivalent fraction, we have to multiply the same by the same number to our numerator and to our denominator. So I'm just going to choose 2. Okay, and I'm going to multiply 6 times 2, which is 12, and 8 times 2, which is 16. So that means that 6/8 is equivalent or equal to 12/16. Okay, and another way to find an equivalent fraction is to divide. So if I take my 6/8, I'm also going to have to divide the same number at the top, or the numerator, that I do to the denominator. Okay, and so I'm going to do by 2 again, because I know 2 can equally go into 6 and it can go into 8. So 6 divided by 2 and 8 divided by 2. So 6 divided by 2 I know is 3, and 8 divided by 2 I know is 4. So what do I know now? I know that 6/8 is equal to 12/16, which is also equal to 3/4. Okay, so remember, to find an equivalent fraction, you can either multiply or you can divide. But you just have to remember, if you're going to multiply, you multiply the same number to the numerator and the denominator, and same for division. You have to divide by the same number for the numerator and the denominator. All right, now let's look at number 35. Okay, number 35 says compare, and we're going to use greater than, less than, or equal to. And our two fractions that we're going to compare are 6/6 and 5/6. So what do I know about these fractions? Well, I know that if I drew a picture, I would have to have 6 equal parts-ish, right? Let's see if I can do better on this one. 3, 4, 5, 6. 1, 2, 3, 4, 5. 6. So these don't really quite look equal, but there's 6 parts, right? So 6 parts of 6 means that this is one whole, right? 6 parts of 6, that actually equals 1. So 5/6, that means I'm going to have 1, 2, 3, 4, 5. That means I still have one piece left over. So which one has more shaded in? 6/6. Okay, so 6/6 is greater than 5/6. Okay, so remember, another way to look at it is on a number line. Okay, and for these fractions, our denominator is 6, so that means we're going to have 6 equal parts between 0 and 1 whole. Okay, so 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Okay, so 6/6 is actually 1. So that's going to be right there. 5/6, I'm going to count 1, 2, 3, 4, 5 is right here. So now I know that 6/6 is also another way to show that it's greater than 5/6. All right, couple more. Let's look at number 36. So this one asks us to order fractions from least to greatest. Okay, and our fractions that they give us are 2/3, 3/7, and 4/35. Okay, so I'm gonna choose to think about it kind of as a picture. So this first one is 2/3. Okay, so that means I've got 2 parts of 3 shaded in. 3/7, this is going to be interesting. 2, 4, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7. Okay, so that means I've got 1, 2, 3. That looks like half, but it's not quite. Okay, so we've got 1, 2, 3. We have 4 left over. Okay, or 4/35. So we're gonna have to try this. It's gonna be complicated. 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35. All just to show that there's going to be a lot of tiny parts, and we're only going to shade in 1, 2, 3, 4 of them. Okay? So it asks us to order them from least to greatest. So which one has the least amount of parts shaded in? Well, 4/35 is the smallest portion that's shaded in. Okay? And then 3/7 has the next least amount. Okay? And then 2/3 has the greatest amount of the whole shaded in. Okay? So that's one way to figure out how to order from least to greatest. Another thing to realize, fourth graders, is that when the denominator gets bigger, it's actually getting smaller. Okay, the pieces are getting smaller, just like you see in this whole right here. Okay, making 35 equal parts means that they're going to be tiny pieces, whereas 2 out of 3, or 2/3, okay, those are going to be big pieces, and 2 of those pieces is a pretty good amount of the whole. Okay, all right, 2 more for today. So number 40, and this one is on page 570, and it shows you a picture, and it asks you to write a mixed number and an improper fraction for each model. So the model is 1, 2, 3, 4, 5, 6. So it's got 3 holes, and each of these is in 1, 2, 3, 4, 5, 6 parts. Okay, and it has shaded in portions, and this first circle is completely shaded. The second circle is completely shaded, and the third circle has all but one shaded in. Okay, so it wants us to write a mixed number and an improper fraction for this. So my mixed number, remember, a mixed number has a whole part and a fraction part. So guess what? I've got 2 whole circles already, 1, 2 holes, and then my fraction part is how many are shaded in. So I've got 6 total pieces, and 1, 2, 3, 4, 5 of them are shaded. So the mixed number for this model is 2 5/6. Okay, so now an improper fraction, how do I write that? Well, it's going to just be a fraction part, and each whole has 6 pieces. So I already know my denominator is going to be 6, but I need to know how many pieces are shaded in. Okay, so this one is 6 whole parts shaded, this one is 6 whole parts, and this one is 5. So I'm going to add those parts together. So 6 plus 6 is 12, plus 5 is 17. So I have 17/6 shaded in, and that's an improper fraction because the numerator is greater than the denominator. Okay? All right, last one I'm going to model for you is number 42, or 43, I'm sorry. So it asks us to change a mixed number into an improper fraction. So 2 3/4. Okay, so that means I can either show a picture like we did in the last one that I just showed you, right? Kind of work backwards. So that means all my circles are going to have 4 equal parts. And I have 2 holes plus 3 more parts. okay? So that means if I were to write it as an improper fraction, each circle has 4 equal parts, and I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 parts shaded in, okay? So that's the easiest way for you to model or go between a mixed number and to an improper fraction, okay? Another way to show it, and if you end up having like a bigger part that is hard to draw, okay, you can look at the example on page 570 that is on the left side next to these problems, okay, and it shows you how to work by adding the fractions and dividing, okay? All right, see you later. Bye.